In this video, you're going to learn how administrative distance and longest prefix match rule affect route selection for Cisco devices. So to start with, every routing source has administrative distance, whether it's a connected route, a static route, a default route, OSPF, ERGRP, or BGP. They all have an administrative distance. And the higher that administrative distance is, the less preferred that route is. So for example, ERGRP has an administrative distance of 90, while OSPF has an administrative distance of 110. So ERGRP routes, when advertised, would be installed in the routing table over a route from OSPF to the same destination, or the same network address. And also, if you have a static route, that has an administrative distance of 1. That is preferred over any dynamic route, since it has the lowest administrative distance. So when you have multiple routes advertised from multiple routing sources, the route that is installed in the routing table is the one with the lowest administrative distance. That's the first thing to understand. When Cisco is deciding what routes to install in the routing table, it considers all routes with the same network address and subnet mask length as to the same destination. If you have a different subnet mask length, even though it's to the same destination, the Cisco devices will install that in the routing table, since it considers it a different destination. And that's important to know as well. And once the routes are installed in the routing table, then the routes are selected based on the longest prefix match rule. What you'll have in a routing table is routes to the same destination, and some will have a different subnet mask length based on the reason I just described. So the Cisco device will select the route with longest prefix match of all the routes to the same destination. What I've got here is a topology. I've got a DC1 router, I've got R1 router, and R2 router. R2 router is running ERGRP, while R1 is running OSPF. So the link between DC1 and R1 is OSPF, and the link between DC1 and R2 is ERGRP. I've got 2 servers connected to this R1 router, and 1 server connected to R2. Server 1 is 172.16.133/27. So the network address for that server is 172.16.132. The first IP address available is 172.16.133. That's because it's subnetted with a /27 subnet mask. And the default gateway is 172.16.134/27. That's gig 002. So server 1 is on a different subnet than server 2 and server 3. Server 2 and server 3, however, are on the same subnet. And I've configured it like this to show you how administrative distance works. So they're both in 172.16.1 network address. Server 2 is .1 and server 3 is .3. They're in the same subnet. So R1 will advertise those routes to DC1, and R2 will do the same thing. R1, however, is advertising OSPF routes, and R2 is advertising ERGRP routes. This is to DC1. I'm going to do a trace route to start with to the servers. This is to server 1. And you have to do it twice with packet tracer. So the route's available. It goes 192.168.1.2, then arrives at 172.16.133. So there's the next hop, 192.168.1.2, gig 000R1. I'm going to trace route to 172.16.1.1. So I'll do Shift Control 6. I'll trace route to 1.3. And that's working okay. So the route to server 1 is there. The route to server 2 is not. The route to server 3 is. The reason is they're both advertising the same network address. However, ERGRP has a lower administrative distance. That's why it's being selected over the OSPF route. And I'll show you this in the routing table. So the D is ERGRP. So 172.16.1/27. It's saying take 192.168.2.2 for that network address. So this is 192.168.2.2. So this is the ERGRP is getting installed in the routing table instead of this OSPF route to server 2, although they both have the same network address. There's the OSPF route to server 1, 172.16.132/27 via 192.168.1.2. And that's this server 1. That's taking next hop to R1. I'm going to do a shut on this R2 gig 001, and that will permit the OSPF route to be installed in the routing table of DC1, since the RGRP route won't be advertised to DC1. Do a shut. There it is. So R2 gig 001, that's a shut. Now DC1 will install the OSPF route with the higher administrative distance. There it is there, the top, 172.16.10/27 via 192.168.1.2. There it is there. Now it's taken R1, and the route's in the routing table. I can do a trace route. See, now it's working. 172.16.11. If I try 1.3, it's not going to work. So 172.16.11. There it is there. So that is working, and the RGRP is not. 172.16.13. Now I'll re-enable this interface on R2, reinstall the RGRP route in the routing table of DC1. Okay. Go back here. And there it is again. There's D. That's for RGRP 172.16.10/27 via 192.168.2.2 exit interface gig 001. So there it is there again. So that's working again. If I trace route to 172.16.1, it's no longer available. That's based on administrative distance. Shift Control 6. Stop that. Now what I'm going to do is configure a static route, and that'll replace the RGRP route since it's got a lower administrative distance. And I'll point the next hop to 1.2 so it goes to server 2, 172.16.11. So the static route from left to right, to get to 172.16.1.0/27, take next hop 192.168.1.2. Okay, and I'll look at the routing table now. Sure enough, there's the static route. There's no EIGRP or OSPF route. So it's static route 172.16.10/27 via 192.168.1.2. So it's taking this next hop here. So as you might guess, if I do a trace route to 1.1, it'll work. It's like that. If I do a trace route to 1.3, it won't. The reason is it's sending out to this next hop. However, 1.3 is over here on R2. So Shift Control 6. Now I'll show you how longest prefix match rule works. What I'm going to do is install another static route. I'll give it a longer subnet mask, and I'm going to use the next hop of 2.2. Now it'll be preferred over this one, going to 1.2, and we'll select server 3 with the same network address. So I just up arrowed there. Now I'm going to change this to a longer prefix. So we'll say 240. So that'll be a /28 subnet mask. Now I'm going to change the next hop to 2.2. I'll show you the routing table. So what I've got is both static routes are there, since when you have different subnet mask lengths, Cisco considers them different destinations, so they're both installed, even though they're actually the same network address. So they're both installed there. You can see the administrative distance is 1. And the top one is going to 192.168.1.2. That's the first one I configured. And the next one is a /28. That's via 192.168.2.2. Now they're both there, Cisco now considers them to be the same network address. However, it will now select the /28 and go to R2, 192.168.2.2. So try this again. So trace route to 172.16.1.1 is not going to work now, because I've got a /28 route that's pointing to 192.168.2.2, and that's R2. It's just timing out there. So stop that. Now I'll just trace route to 1.3. Just do it again. There it is, 192.168.2.2, then 172.16.1.3. So that's what it's doing. Based on longest prefix match rule, it's selecting the route from DC1 to R2, and then to server 3, 172.16.1.3. There's the next hop, 192.168.2.2. So with the CCNA exam, it's important to know how to interpret routing tables, as well as know how administrative distance and longest prefix match rule affect route selection. That concludes the video.